I am going to post model paper number 3, electronics part. I have been continuously posting nowadays electronics model papers with a view to help those who wanted to prepare for hand-ready examination. It will be useful to both the grades, general and restricted. Already I have shared enough videos with regarding to communication procedure. That is more than enough. Those who follow my videos, they can easily qualify restricted and as well as general grade. Those who wanted to get a special training for Morse code and communication procedure electronics, they can join on ham radio training program scheduled to be held on May 10th, Sunday at 6 p.m. Now I am going to discuss about model paper number 3. The capacitor is a passive device. Alpha is the option. Alpha is the right option. Active device means all the semiconductor components like diode, transistors, all these things are active devices, but capacitor is a passive device. Next question. The frequency of sinusoidal signal Vt is equal to 5 sin 100t volts. Yes. So we have to calculate the correct option. Actually, correct option is 100 by 2 pi cycles per second. This is the answer. How we have got this answer? Step 1. Compare with the standard form. This is the standard form. Vt is equal to Vm sin omega t. So we identify peak voltage Vm is equal to 50. So peak voltage Vm is equal from the given formula 50. Angular frequency is equal to the formula omega is equal to 100 radians per second. This also omega in place of this 100t means from this formula this is nothing but omega. So omega is equal to 100 radians per second. Calculate the frequency. So to calculate, to make it omega is a angular frequency. To make it regular frequency, you have to divide it by 2 pi. F is equal to omega angular frequency by 2 pi. Substituting these values, omega means we already know 100 radians. So final answer is 100 by 2 pi h. So correct answer is Charlie is the correct option. The RMS value of a sine wave signal is, the correct option is 1 by 1.414 times the peak voltage. Here for sine wave signal, the RMS value is Vrms is equal to V peak by root 2. Since root 2 is equal to 1.414, so Vrms approximately V peak by 1.414, approximately 0.707 volts. Vrms is equal to approximately 1.414 V peak, that is equal to approximately 0.707 voltage peak. So correct answer is Charlie, 1 by 1.414 times the peak voltage. The transmitter power amplifier requires 300 milliamperes at 300 volt. The DC input power is. Here by applying the formula, input power is equal to P is equal to V into I. So we know the V is 300 into I is 300 milliamperes. So we'll convert this into amperes. That is 0.3 ampere. 0.3 will make it 0.3 amplifier. 300 into 0.3, 90 watts. So answer is 90 watts. 300 into 3, you can write like this also. 300 into 3 by 10. So we'll get 30 into 3, 90. The metal plate separated by air form 0.003 microfarads capacitor. Its value may be changed 0.001 microfarads. So what is the correct option here? Moving the plates apart. If the plates are moving, increasing the distance between the two plates, so that will change the capacitance higher value to lower value. So moving the plates apart is the correct option. An inductor and a capacitor are connected in parallel at the resonant frequency. The resulting impedance is maximum. Maximum is the answer. When they are connected in parallel like this, inductor and a capacitor. So this is the L and C. So these both reactances are equal. That is X1 is inductive reactance is equal to Xc. And they will get cancelled. So resulting impedance is, it will be maximum. This is called parallel resonance. Series resonance occurs when inductance L and capacitor C connected in series. It will be like this. Series inductance. Impedance will be minimum in this case. Now, the following type of oscillator will be more stable. That is crystal oscillator. Almost it is stable. There won't be any drift in the frequency. The length of a dipole for a signal frequency 50 megahertz is 3 meters. 50 megahertz. The length of a dipole for a signal frequency of 50 megahertz is. For a half-wave dipole, the practical formula is L is equal to approximately equal to 150 by F. This is the formula I have to remember. So F is equal to 50 megacycles. It has been given. So L is equal to 150 by 50. It becomes 3 meters. The correct answer is 3 meters. The frequency 7100 kilohertz can be transmitted by, this is the HF frequency. So naturally it will be transmitted by ionospheric propagation. A current of 0.5 ampere flows through a resistor when 6 volts is applied. To change the current, that means current has to decrease. So then 0.1 ampere, the resistance must be more. But we have to reduce 0.5 to 0.1 ampere 5 times. So resistance you have to increase 5 times. That is R into 5. This is the correct option. An isolating transformer is used to ensure that no voltage is developed between the output leads. It is completely isolates. A varactor diode acts like a variable capacitance. Varactor diode is something like a by changing the voltage and cathode, we can alter the capacitance. So it will act like a capacitance. The frequency 146 MHz can be transmitted by, it is space-wave propagation. So tropospheric and certain conditions only, when the duct is formed. Ionospheric propagation, that is purely HF. Ground wave is below 2 MHz. So the correct option for this 156 MHz is space wave propagation. The most suitable antenna for receiving VHF range is Aggie antenna. The color bands of a 47 kilo ohms plus or minus 10% resistor are 47. 4 means yellow. We have to write like this: 47 kilo ohms means 47. K means 3 zeros. So this is the ohms. Yellow, 7 is violet. 3 zeros we need, so orange. And the final one is 10% silver. Yellow, violet, orange, silver. Yellow, violet, orange and silver. This is the answer. Charlie is the answer. A signal FM is amplitude modulated with a carrier FC. The frequency value of lower sideband is, this is modulated frequency, this is the carrier frequency. So the signal frequency is FC minus FM, carrier frequency minus modulated frequency. This is the correct option. Charlie is the option. The doping concentrations of emitter, base and collector in NPN transistor is, see here, emitter will be heavily doped, HEAVY. Base will be light. And collector will be moderate. Heavy, light and moderate. Heavy, light and moderate. Bravo is the correct option. The wavelength of a signal Vs is equal to 5 cos 6 pi 10 square t is, here to calculate this one, you will get none to this. Given signal is Vt is equal to 5 cos 6 pi into 10 to the power t. This is the actual formula. Vs means Vt. Compare with standard form cos omega t. Here omega means, by comparing this, omega means 6 pi 10 to the power of 10 square. So 5 omega is equal to 6 pi 10 to the power of 2 is equal to, this is 100, 600 pi radians by second. Next, to change this angular frequency omega, we have to divide it by 2 pi. Omega by 2 pi is equal to 600 pi by 2 pi is equal to 300 edges. 300 edges. 600 by 2. Wavelength is equal to, wavelength lambda is equal to C by F. So we know C, that is light speed, 3 into 10 to the power of 8. F means this is the frequency, just that is 300. is equal to this one. This is lambda is equal to C by F is equal to 3 into 10 by 300. So it always, it becomes automatically 300 means this 3 by 300, it becomes 100, 10 to the power of 8 by 100, that becomes so by divided, so it is 1 into 10 to the power of 6. This value is not in the given options. Correct answer, none. The mutual inductance M between two coils of self-inductance L1 and L2 respectively can be expressed as M is equal to K into root of L1, L2. L1 is the inductance of first coil and L2 is the inductance of second coil. So this is the correct option. The power conversion efficiency of full wave rectifier is 81.2%. The length of reflector, dipole and director of Agee antenna in terms of wavelength are reflector, that will be very big element. Very big is 0.55 lambda. Dipole is it is medium size. So medium size here in this case 0.5 lambda. And then this director is a small one, that is 0.45 lambda. So in this sequence 0.55, 0.5 lambda and 0.45 reflector, dipole and director. Alpha is the correct option. The input to an amplifier is 1 volts RMS and output is 100 volts RMS. This is an increase of, to calculate this voltage gain in decibels is given by GdB is equal to 20 log V out by V in to the base 10. So here in this case V out by V in, it becomes V out, we know 100 from this, it has been given. V in is 1. So 100 by 1 is equal to 100. V out by V in. So GdB is equal to substituting these values 20 log V out by V in, that is 100. So 100 to the base 10. Here in this case 20 log 10 square to the base 10. So this 2 into 20, this 2 into 20, it becomes 20 into 2, 40 dB, total 40 dB. Log 10 to the base 10, that is equal to 1. So 40 into 1, 40 dB only. So correct answer is 40 dB. The oscillator that makes a communication receiver capable, there is a beat frequency oscillator. Beat frequency oscillator, it operates nearer to the interrupt frequency. Suppose for example, intermediate frequency is 455 kilohertz and beat frequency should operate on somewhere else 2 megacycles plus or minus. Here in this case, it will becomes 257 kilohertz. So the difference is 2 kilohertz. So this frequency, it will be in audible range. A super heterodyne receiver with an IF 500 kilohertz is receiving a 14 megahertz signal. The local oscillator frequency is we have to find the local oscillator. The local oscillator frequency is equal to signal plus IF. So IF we know 500. Receiving a 14 megahertz signal. 14. So 14 plus 5, 14.5 megahertz. Localized frequency is 14.5. This is the answer, option. In the transmitter black diagram shown, the mixer, the function of this mixer is translates the SHV signal to the required frequency. Here is, in this case only, the frequency will changes depending upon the VFO's frequency. So that's all from this side. We'll meet again with some other model paper or some other topic. 73 is bye for now.